Hello students, myself Rajani Hardas. Today I am going to cover the topic Superposition Theorem under the course Basic Electrical and Electronics Engineering. Reflection spots are on the slide numbers 2, 3, 4 and 8. This theorem states that in a linear electrical circuit with multiple independent voltage and current sources, the voltage or current at any component in the circuit is the algebraic sum of voltages or current due to each source acting alone while other sources are turned off and they are replaced by their internal resistance if any. Reflection spot number 1. What is a linear circuit in electrical network and what is the value of internal resistance of an ideal voltage source? What are the conditions for applying superposition theorem? The circuit must be a linear circuit. There must be an independent voltage and current sources. If circuit consists of dependent sources, then they have to be handled separately. This theorem mainly applies to independent sources. Reflection spot number 2. What are the independent and dependent sources? What are the steps to apply superposition theorem? Step 1 is to identify all independent sources. Step 2, consider one source is acting at a time and remaining other sources are turned off. Step 3, analyze the circuit and find out current flowing through particular branch due to this source. Repeat step 4, repeat the process for each independent source in the circuit. Step 5 is to sum up effective contribution of all sources to get the total voltage or current flowing through particular resistance. Reflection spot number 3. What are an active and passive energy sources? Now this superposition theorem is discussed by considering a simple example which consists of two voltage sources VDC1 and VDC2 with two resistances R1 and R2 respectively, and it is asked to find out current flowing through this 3 ohm resistance, that is R2, by applying superposition theorem. So step number 1 is to find out all sources. Step 2 is to consider one source acting at a time. Therefore, VDC2 is turned off from the given circuit and it is replaced as a short circuit. Then calculate current flowing through circuit or current flowing through this 3 ohm resistance, which is denoted as I dash. Due to VDC1, the direction of this I dash current is downward. Then in next step, turn off VDC1 and replace it as a short circuit and calculate current flowing through this 3 ohm resistance. Now it is denoted as I double dash and its direction is upward. Then add effective sum of individual currents I dash and I double dash due to VDC1 and VDC2 voltage sources respectively. In this example, current flowing through this 3 ohm resistor is opposite to each other. Hence, total current I will be equal to I dash minus I double dash. So, what are the key points to remember while solving this superposition theorem? Is that first, it is only applicable to linear circuit. Second, when turning off a source, if it is a voltage source, then it has to be replaced by a short circuit, and current source is to be replaced by an open circuit. The final voltage or current at any component is the effective sum of individual contribution from each core. So, reflection spot number 4. Why superposition theorem is applicable only to linear circuit? Next, advantages of superposition theorem. It simplifies complex circuit. It is helpful for understanding source contributions, and it is effective for analyzing linear circuit. Then what are its limitations? It is non-applicable to non-linear circuit, and if circuit is a large circuit, then it's a time consuming process. So what are the real applications of superposition theorem in our LED TV, micro oven, computer systems, our smartphones, then in drone applications, in robotics tool applications, in digital camera, and many more applications are there. So at the end, this superposition theorem is a powerful tool for analyzing linear circuits with multiple independent sources, and by simplifying the analysis, it enables engineers and students to understand how each source contributes to the overall behavior of a circuit. Thank you.